Right. So this is a part of a series of geometry problems that I'm planning to talk about in the next few videos. So it says there are two circles C1 and C2 of equal radius r. Their centers are at a distance r from each other. What is the area of the region that is common to C1 and C2? So let's draw a picture and that will probably clarify things for us. So I have two circles here, circle 1 with a center, and circle 2 is also of radius r, and its distance from the circle of center of circle 1 is also r. So its center is somewhere on this circumference, and this circle 2, I'm drawing it a dotted circle, is basically going to pass through circle 1, through the center of circle 1. So let's call this A and let's call this B. So A is center of C1, B is center of C2, and the two circles are passing through each other's centers. So now there is this common area, it looks like a lens, and we want to calculate this area. Okay, so let's see what we can do here. So I'm going to draw another picture, maybe slightly better and a bigger picture here. So this is circle 1, this is circle 2. Let's give these points names A, B. Let's call these points of intersection C and D. So I'm going to draw these dotted lines to make us visualize these things better. So note that triangle ABC and ABD are equilateral triangles because each of these sides is R, R, R. Everything is R here. All the sides are R. So triangle ABC, triangle ABD are equilateral. This might be useful. So, but still, how do we calculate the area? Because this is an irregular shape and we cannot directly calculate its area. So the one thing to note here is, so I'm going to focus on this circle with center A. So this circle, this circle that I'm focusing on. So let's look at this arc A from A to CBD. So, and can I calculate this area first? Let's see this full area. Not this area of this dotted region here, not this dotted region, but just the region with the lines. And that should be possible because this angle CAD is equal to 120 degrees, because this is equal to angle CAB plus angle DAB, and these are both 60 degrees angles because the triangles are equilateral. So this is 120 degrees. Okay, so angle CAD is 120. This angle is 120 degrees. So this shaded region is basically 1/3 of the circle. So the full circle is 360 degrees, and now I have a region of the circle that is 1/3 of the circle. So area of the shaded region is 1/3 times the area of the circle, which is pi r square. So let's call this one and let's remember this. So the area of this shaded region here is 1/3 pi r square. So that's good to know, but we have to also calculate the area of the dotted region. So now the question is, what is the area of the dotted region? Let's see, let's find that out. So this dotted region is, again, if I look at this from the point of view of the circle with center B, let's focus on this circle now. Then this dotted region is basically 1/3 of the circle minus these two triangles, and they are both equilateral triangles. So dotted region is basically 1/3 of circle minus 2 equilateral triangles. So area of the dotted region is 1/3 of the area of the circle, which is pi r square, minus 2 times area of equilateral triangle is √3 divided by 4 times side square, which is r square. So this becomes 2. So which is 1/3 times pi r square minus √3 divided by 2 r square. So now we have all the ingredients here. So common area of the two circles of two circles C1 and C2 is equal to, let's call this 2, is equal to 1 plus 2, which is, what was 1? 1/3 pi r square plus another 1/3 pi r square minus √3 divided by 2 r square, which is 2/3 pi minus √3 divided by 2 r square. So that's it. That's the area of the that's the common area between the two circles. And the way to approach these problems is to, as we did here, is to break the given area into smaller regions that we can calculate areas of. So we can calculate the area of a section of a circle, rather a sector of a circle, or of equilateral triangle, or a rectangle, or a rhombus. These areas are easier to calculate. So we want to break the given area into smaller chunks that are easier to manage, and then we calculate their area. So that's what we did. We first calculated the area of the sector with center A and the CBD, which is 1/3 of a circle. So that's 1/3 of a circle, which is pi r square. And the second one was again 1/3 of the circle minus 2 times the area of the equilateral triangles. And so finally we got this 2/3 pi minus √3 divided by 2 r square. As a sanity check, let's just confirm that this number is positive and I did not make any mistakes. So this pi is 3.14, but let's say it is 3. So two-thirds of this is 2, and √3 divided by 2 is around 0.86. So yeah, this whole number is positive, so it passes sanity checks. Okay, so that's about it.